Hi, it's Mr. Benson here again with our next video, which is on looking at volume of prisms and cylinders. So again, where are we at? 12.7 in the text, page 456. We want to be able to find the volume and capacity of a variety of prisms and cylinders, which, as we've seen, behave in a lot of similar ways. Okay, so when we're talking about volume, what we mean? So it's the amount of space occupied by a solid object. So here's a nice simple solid object, a rectangular prism. We can figure out the volume of that object. So one of the ways to think about this is just to think about a simple object, so a cube with sides of 1 centimeter, like this. And by definition, the volume of this cube is 1 centimeter cubed, or 1 cubic centimeter is the kind of preferred way of saying it. But we would write it as 1 cm to the power of 3 or cubed. And then when we're thinking about how much volume something takes up, all we're really thinking about is how many little cubes go into making up our larger solid. And that's really easy to think about when you've got a regular shape and it's already kind of divided up into regular chunks, like the one on the left hand side, where we can see that we've got 3 cubes across the bottom. We've got 2 cubes on our width here, and we've got 2 cubes in our height. So we can figure out pretty easily that we've got 12 cubes, and so our volume there must also be 12 cubic centimeters. When it comes to converting units of volume, we've got to be careful in the same way that we were with the conversion of units of area. So when we are thinking about units of volume, we've got to remember that the unit is cubed, because we're talking about meters cubed and that sort of thing, and that means that our conversion factor is also going to be cubed. So when we look at our examples, or in our conversion table here, when we're going from millimeters to centimeters, now if we were just thinking about units of length, well, we'd be dividing by 10 because there are 10 millimeters in a centimeter. But we've got to cube that in this case, so instead we are dividing by 10 to the power of 3, or 1,000. So if we had 1,000 millimeters cubed, then that would be 1,000 divided by 1,000 to give us 1 centimeter cubed. So our conversions are just obviously a lot larger because everything's cubed, but I would suggest that you put these conversion tables on your reference sheets if you're a little bit unsure. Now we also need to talk about capacity, which is a slightly different idea to volume. So volume is the amount of space that a solid object takes up, but capacity is the volume that can be held within a container. So they are slightly different, and I'll clarify that in an example shortly. When we're talking about units, the unit of capacity is generally the litre. And again, we have conversions here from milliliters to litres and kiloliters and stuff like that, which are just going up 1,000 each time. That being said, you will occasionally come across units like centiliters and possibly deciliters and things like that, depending on what sort of products you're looking at. Just to be extra confusing, these units that we see in terms of capacity, so litres and kilolitres and things like that, are really interchangeable with units of volume, and you often will see them being interchanged anyway. So when people are talking about kilolitres down here, so 1,000 litres is the same as a cubic metre. So it's not uncommon that when people are talking about capacity and volume, they will occasionally switch between the two, and that's fine. Just be careful with questions that you follow the units that are in the question. So if a question's talking about litres, generally you're going to answer in litres, or if a question asks you to give a specific unit, then you should give that specific unit. So when we're talking about capacity versus volume, so any 3D object has volume, but it won't have any capacity if the object is hollow. So if we look at two bricks, for instance, you can see that they will have similar volume because their dimensions are going to be pretty similar, but one of them has capacity and one of them doesn't. So the volumes of the two bricks would be the same, but the brick on the right would have capacity, the brick on the left would have no capacity because it's solid. There's no space inside it to hold any other substance. Volume of a prism or a cylinder. Now, they all follow exactly the same formula, and it's just really how we get to these things that is the only difference. So for any prism or cylinder, all we've got to remember is that the volume is the area of the base multiplied by the height. So remembering that with prisms, and we're always talking about right prisms at the moment, and cylinders, you always have sides which are perpendicular to your base. So as long as you know the area of your base, and you can multiply that by the height of the sides that are perpendicular to the base, then you can get your volume. So if you recognize that, working out volume is pretty easy, but it's worthwhile just highlighting some other variations on that. Now, what that means as well is that you can actually do volume calculations with irregular shapes that we might not necessarily have a formula to calculate the area of. If the question tells you the area and also gives you information about the height, then in this case we can just apply the simple formula up here. So V equals A times H. So in this case it would be 17 square centimeters, or centimeters squared I should say, multiplied by 4 centimeters, and we would end up with 68 cubic centimeters there. Volumes of cubes and rectangular prisms. Now again, these are both the same idea. So all we're thinking about is multiplying the area of our base of the shape by the height of the shape. Now it just happens that when you've got a cube, the length and the width and the height all have the same value, so we can just say that the volume of a cube is the side length cubed. When we're looking at a rectangular prism, then the side lengths may be different. They could all be different, or you might have one that's different or something like that. And so you just do length times width times height. Other prisms are not really any more difficult as long as we can figure out the area. Now, all we're really thinking about at this stage is that we want to be able to find the area of, shapes, the relatively simple shapes that we've looked at in the previous videos. So, you could do a trapezoidal prism or something like that, as long as you've got sufficient information to calculate the area of the base, which, the formula is pretty simple and the question should give you that information, then you could calculate that. So for this question here, we could think about it a couple of ways. We've got to think about our area here, and the area of a triangle is half of the base times the height. Now in this question we're given the base and the height. That's nice and easy, and so all we've got to think really is our volume is our area multiplied by our height. So this is going to be now of course that's kind of confusing because we've got two different heights here. Scratch that. I'm just going to say, for the purposes of this example, I'm going to refer to that as the length of the prism instead. So that means we're going to have half of the base times the height of the triangle multiplied by the length of the prism. And look, as long as you keep track of your numbers in your substitution and your algebra, what you call them doesn't really matter that much, as long as it's pretty sensible and clear what you're doing. So we multiply these together and we get 48 cubic centimeters as our answer for this one. Okay, so volume of a cylinder, again, exactly the same idea. We've just got, so volume is just the area times the height, And remember that our area of a cylinder, of a circle at the end of a cylinder is just pi r squared. So volume is going to be pi r squared times h, or pi r squared h if you just want to write it in a slightly shorter version. Now, we can also do volumes of composite shapes to figure out volume or capacity, depending on really just on what the question's asking you. So you might also do this, like we talked about with areas, where you might do it by addition or subtraction of the components. So if we think about this object on the left, we've got a I have no idea if that was a cube or not actually. So we've got a rectangular prism here, and we've got a cylinder on top of it, and we would be adding these together to figure out our total volume. Then you've got a brick over here where we might be able to ask a few different questions about it. So one thing we've got is that there is obviously the volume of the brick itself, just very crudely, is a rectangular prism. But if we wanted to know how much clay was required to actually make the brick, then we would need to subtract these circular parts here. But we might also be looking at a different question, which was, say we wanted to fill the brick with another substance in these holes, so we might also want to think about what the capacity was of the holes. So the holes themselves are cylinders, so the capacity of the holes would just be the sum of the three cylinders, whereas the volume of the clay required to make the brick would be the rectangular prism of the brick itself minus the three cylinders. Okay, so let's have a think about one of these sorts of examples. So if you remember in the previous video, I was living in a pipe in an abandoned vacant lot, but in this example, fortunately, I've moved up in the world. So Mr. Benson has moved up in the world and is now living in an old septic tank. The tank is 3 meters square and 2.4 meters high, and each side is 20 centimeters thick. What is the volume of the tank? So volume is easy. We're just thinking, how much space does that whole object take up? Now, sorry, the diagram is just meant to show that, it's a cutaway into the tank where, I'm perhaps living happily, hopefully. There we go. So we're just really meant to think of the tank as being a rectangular prism. So what is the volume of the tank? So volume is area times height, or volume is length times width times height for the tank. And so we've got length times width times 2.4, and we get 14.4 meters cubed is our answer there for the volume. So that's fairly straightforward. Okay, now we're going to move on to a capacity question. So everything's the same, but now the question is, how much hand sanitizer is required to fill the tank? So now we've got to think about not the external dimensions of the tank, so not the ones that we used in the previous question, because while that tells us about the volume of the tank that whole object takes up, the amount of space that takes up, it's not telling us about what's inside the tank in this volume here, which is the empty space that we can then fill with the hand sanitizer. So this is the capacity of the tank that we need to think about. What you've got to be careful with in questions like this is just remembering that the dimensions are going to change, because we've got a 20 centimeter or 0.2 meter thickness. So that's 0.2 meters is the thickness of the sides. So that means that if our external width was 3 meters, it means that our internal width would be reduced down to 2.6 meters, because we're taking off 0.2 meters on each side. So what this means is that our length, which equals our width, would be 2.6 meters, and our height, which is also going to be reduced by 0.2 meters, would be down to 2.0 meters. And so then our volume is just given by length times width times height. So just these numbers multiplied together, and we end up with 13 I'm just going to round that to 13.5 cubic meters. Now, given what we were saying previously about what might be an appropriate unit for this one as well, given that we are talking about capacity, that would be the same as 13,500 litres of liquid. Alright, summary. All we've got to remember here is that the volume of a prism or cylinder is given by the area of the end multiplied by the height, and so as long as you've got the area formulae handy, you can work out the volume of any right prism or cylinder, or any shape that is that has sides that are perpendicular to the base, as long as you're given the area of that shape. So what to do now? Same again, attempt the exercises and email your teachers if you get stuck.